I try to do schedule every day and skip religion. Happy birthday! Happy birthday! Thanks. I was saving it for class, you know, just so I could run up to you and give you a hug like that, you know?
Alright, so what I want you to do, make sure your tests are up here. Make sure your tests are up here. Your triangle, cut a triangle out, rip 3 corners off. Now I want you to take a minute, take your 3 corners, and try to put them together like a puzzle. So just take a minute, try to put your 3 corners together like a puzzle.
It kind of like rips though.
Yeah, that's right. So put your, maybe you want to try another one.
Taylor, your mom confused me.
When she said it last night.
Yeah, I was like, wait, I thought it was tomorrow.
And then people started telling me last night, I was like, my aunt from Wisconsin. I was finding me and you writing this.
No, I had to I got on Facebook and read back to my calendar and I was like, is that her birthday tomorrow?
Yes.
I am. See, I'm done.
No, don't put it back on your triangle.
How do I
What do you mean?
Sorry,
I don't think
cut out a triangle.
I'm so
Rip off the 3 corners like that.
What?
Put them together. Just the 3 corners.
Just not this.
Now back on your triangle, Jason.
And cut out a big triangle. So can I just do this?
Sure.
Oh yeah, I have a suggestion. Okay. I'll tell you after I cut my triangle.
I still have to get work.
Oh wait, I need to get my test on here so I can cut out a. Where's my box?
Why am I not doing good at this?
You'll be alright. Keep going. Keep trying. Yeah.
I just.
I'm done.
Did it make anything?
Yeah, makes another time. I don't know. I'm back together.
Looks pretty good to me.
What? This is not.
What is that supposed to be?
What does it make?
Straight line.
This is not moving.
Oh. Oh, I could have done that 10 hours ago.
Wait, does it have to do with
If I knew what this was, I would tell you.
It's not anything. Look at mine.
He just told you. Oh my gosh, I'm not in those retards today.
Nice. Sarah.
I cried, you're so mean. What? I can't.
Yeah, you can. Keep going. Keep trying. Alright, so look. Watch up here. This is what you do. The sides that you ripped off, you should have one tore up side, and the other 2 sides should be the cut sides, right? Or the straight sides. Put 2 of the straight sides together so that the vertexes, the vertices are touching.
Okay, I'm just gonna use my other triangle because I cut it.
Yeah, you sure can. Then put the other one so that all 3 of the corners are touching.
Computer's been being so tall.
Yeah, it might look a little.
Cute. Cute. Does that work though?
Well, here you got this one turned. That's the wrong one. And this one. Look,
Oh. Okay.
I could never stop it from. Got it backwards, Jason.
What's your birthday? You have your birthday? Oh, that's it. What?
Oh, that makes sense.
So, what we're doing, you take all 3 corners of the triangle. Watch now. This is one of my corners of my triangle, right? This is another of my corners. This is the 3rd corner. I take all 3 corners. I put all 3 corners together so they're all at one point. And what's formed along the bottom? Straight line. What do you know about a line? What's the measure of any straight angle? 180. So when I took this corner, this corner, this corner, and I put them all together, they all totaled up to be how much? 180. What's 3 corners of a triangle always going to total up to be? 180. That's one of the rules that we're going to cover today.
thought I was having to make like a shape out of it or something.
Just so if you put all three corners, that's one corner, two corners. That's probably what I should do. With the next class, I'll probably make them mark it like at 1, write a 1 in there, write a 2 in there, write a 3 in there. You stick all those together, you can see that it's going to form a straight angle. All right, today is what is today? 3rd, 4th? Today is the 4th. Go ahead and start copying this down. Notebooks will be due soon, so make sure you're keeping your notebook caught up. Chapter 3, Chapter 4, theorems and postulates.
Wait, can you tell me who I know?
Oh, I'm gonna get my test. The last notes I have in here is from 13.
Yeah, that's probably about right.
These are how much? I was like 205.
Now you're missing something.
I'll think about it.
The chapter review, you probably used it.
I don't have a break for it in my, I don't have the chapter 3 review thing.
No, that's 2 separate things. Chapter 3 review notes,
Oh,
because you probably used it on your test. Remember I said you could use that one
oh.
paper, and you probably wrote it on the back of a handout.
Well, what is a chapter 3 review? I can have this packet and
Packet.
because I don't have grade
I'm not
for
really
it.
going to.
I'm not gonna have a phone. You said a phone.
Well, no,
I mean,
I'm just saying.
what I should do?
So did,
Like this. About like
You woke up really late though. I was like, get something to do. He said, that, you guys found it. I don't care, it's fine, I'm late all the time. Why didn't I finish that?
Did you absent that
I think
day?
it's what, after.
Maybe.
Did you take the test late? I don't remember.
Yeah, I have a.
So you probably weren't here that day. Laid up on my chest, laid on my chair. So we're going to start covering chapter 4. Try to get through quite a bit of chapter 4 before the semester exam. Be able to classify triangles, sides, and angles. The other day when the sub was in here, you probably did some of this, so this will be, if you read through it and did what the sub asked you to do,
I have a question.
shouldn't be real difficult.
What is going to be on our semester?
I will pass out stuff and tell you that in a few days.
A few days, I'd like to know now so I can start studying.
Everything that we've covered. Chapter 1, chapter 2,
Okay, what
chapter
about
3,
that,
chapter 9.
slippage? Are
chapter
you gonna
four.
put slope on there? Cause, I'm gonna get that one automatically wrong.
What happens if you get a better? Is that just for your grade?
It's 20%.
In my class, it actually counts as a test grade, and it counts as a,
I'm never good at these kind of things. I always get this like on the OATs and stuff, like when we were younger, because we like went over the stuff that, and we just on like the last few months of school, we like reviewed everything, but I'm not good at this kind of stuff because I don't remember what we went over. I mean, I don't even know what I ate last night.
I'll give you some ideas.
Okay.
Find angles related to triangles. We're going to deal a lot with angles. Talk about a couple of theorems and postulates that deal with angles related to triangles. All of chapter 4 deals with triangles. Go ahead and copy this down.
Wait.
These are different kinds of triangles. You should be able to run through this fairly quickly because you should already know most of these. When you classify triangles, you classify them or you name them according to their angles or according to their sides. We're going to do the angles part first. All right, so ways of classifying triangles according to their angles. First one, an acute triangle, and each one of these should have a triangle. It's an acute triangle, so you don't get it confused with acute angle or anything else that's acute. What's an acute triangle? Jason, what's an acute triangle?
It's a triangle that it has all of its sides are under 90 angles. Angles are under 90 degrees.
All angles less than 90. Kaylee, what's an obtuse triangle?
Where all the angles are obtuse.
Think about it now. Think about it. All the angles are obtuse? Would you guys just tell me about the three angles of a triangle?
Oh, well.
They add up to 180, so can all three angles be obtuse angles? So how many of them are obtuse? One obtuse, oops, spelled obtuse wrong. Obtuse angle. So it's a triangle that has one obtuse angle. You can have all three obtuse. If it had three obtuse angles, you drew one obtuse angle, might look something like that. Then if I tried to draw another obtuse angle, is it ever going to form a triangle? No. So acute triangles, all three angles, less than 90. You can put all three in there. All three angles less than 90. Obtuse has one obtuse angle. What's a right triangle?
One angle is 90.
One angle is 90 degrees. One triangle that has one right angle.
Yeah, I had to spell everything out because I was trying to study for one of your tests, and I was like, what is that? Like, because I can't.
Oh, so yeah. So when you're taking notes, that's a good thing to know about. When you're writing your notes, they're your notes. You're going to use them, write them so that you can understand them. Equiangular. Anybody know what an equiangular triangle is?
All equal sides.
All angles are
All angles are
the same.
the same. So
I didn't
all
think that
three angles
I didn't.
are the same measure. All three angles are the same measure. Now, when you have an equiangular triangle, if I draw an equiangular triangle up here, something like that, that's a pretty ugly one. If I say all three angles are the same, you guys just told me earlier, what do you know about the three angles of a triangle? They add up to 180. Well, if all three of these are the same, could we figure out what each one is? They're acute, but go ahead. 180 divided by 3. What is 180 divided by 3? 60. So in an equiangular triangle, each angle has to be 60 degrees. You might want to write that somewhere there in your notes, because that same measure is always going to be 60 degrees. If they tell you a triangle is equiangular, then right away you know all three angles has to be 60 degrees. All right, labeling them according to their size. Say it this way, some of them, because it's confusing, but the actual definition of an isosceles triangle is at least two sides are congruent. What's that mean? It says at least two sides are congruent. It could be more. So not only could it be, to be isosceles, not only could it have two sides that are the same, but it could have all three are the same. What do you think an equilateral triangle is? All sides are equal.
So, if it's an equilateral, then it's an isosceles?
Exactly. So if a triangle is equilateral, it could also be named an isosceles triangle, but a better name for it would be an equilateral
So,
triangle.
like, if there was a question that asked, like, name, or like, name, I don't know, like, name all triangles, or something?
Name this triangle
Yeah, would you put both of them, or would you just write?
the best name. You just put the best name. So if it is equilateral, then the best name to give it would be equilateral. But they may give you a problem and say, you know, they may say triangle ABC is an isosceles triangle. So that means we know that two sides are the same. And you may be working through the problem and figure out, hey, not only are those two sides the same, but the third side is the same also. So not only is it an isosceles triangle, but it's a equilateral triangle. So all three sides are congruent. Which ones of these do you think we're going to deal with the most? Acute triangles you think you deal with acute triangles a lot? Not really. How about obtuse triangles? Not really. How about right triangles? Yeah, you deal with those a lot. Equal angular? Yeah. How about scaling? Does that give you any information? If I tell you all three sides are different, does that really tell you anything? Isosceles? Yeah. The ones you're going to deal with the most are the ones that give you the most information about the triangle. So isosceles, equilateral, right, equal angular, we deal with those a bunch. Let's look back up here at this triangle. If I know all three of these angles are 60 degrees, not only is it equal angular, but what other kind of triangle is it? Equilateral. So maybe somewhere there in your notes you should write this down. If a triangle is equilateral, and I'm going to use this little symbol here. This is a symbol that we're going to start using every now and then. Anybody have any idea what that double arrow might mean? Make a guess, you're probably right. Sort of equals means
Same thing, and go either way.
exactly, can go either way. So if a triangle is equilateral, then we also know it's equal angular. So guaranteed on the next test that we take, over chapter 4, I'll put a problem on there, and it's going to say something like, triangle ABC is equilateral. Find the measure of angle A. Well, if it's equilateral, what's the measure of angle A? 60 degrees, right? So if you know it's equilateral, then you also know it's equal angular. If you know it's equal angular, it's also equilateral. Just like Kayla just said, this tells us it works both ways. So they tell you it's equilateral, you know it's got to be equal angular. They tell you it's equal angular, then you know it's got to be equilateral. Copy these down. I'll give you a minute or two to copy them, then we'll go over them. We'll probably jot some stuff in for each one, so maybe skip just a little bit of space. Again, make sure in your binders, especially before the exam, make sure you got the theorems and postulates copied down. For this 9 weeks for your binder, so far all you need is chapter 3 and chapter 4, but
I have a copy down, and then I have the theorems I can use when I'm
right, and that's what you should have to get. Yeah, anything that I put, don't, again, anything that's on this up here, these are your notes. This isn't you copying them down in the theorems and postulates thing. This is just my explanation of those theorems and postulates. All right, on this first one, angle sum theorem just tells you that the three angles of a triangle must always be 180. So no matter what the triangle looks like, 3 angles together must add up to be 180. Do not get it confused and say that the 3 angles of a triangle are supplementary to each other. Remember, supplementary deals with how many angles? 2. 2 angles are supplementary. When you get 3 angles or 4 angles or 5 angles that add up to 180, they're not anything special to each other except that they add up to 180. So don't call them supplementary angles. So no matter what, 3 angles of any triangle must add up to equal 180 degrees. The third angle theorem. If I have 2 triangles, and please don't get into a bad habit like I'm into, is every triangle going to look like the triangles that I've drawn every time?
Yes.
No. All right, so don't get into the bad habit of drawing a triangle, and this is what will happen a lot of times. If I ask you to draw a triangle on your paper, a lot of you'll do something like this, and then you'll say, and I'll say, all right, what kind of angle is angle 1? And you'll say, oh, it's an acute angle. Well, that might be true, but do we know that for sure? Did I tell you to make angle 1 an acute angle? No, so don't go by what the drawing is. Crazy pen. But every time I draw a triangle, most of the times I'll draw something that looks like this just because it's easy. That doesn't mean that's the way it has to be drawn. If 2 angles in one triangle are congruent to 2 angles in another triangle, so in other words, if we have something, when you're marking the angles, remember you mark the little arcs. How come I put a little tick mark on this second pair of angles? They're congruent to each other, but they're not what? Congruent to the other 2. So if these 2 angles are congruent, these 2 angles are congruent, what's that tell us about this third pair of angles? They have to be congruent to each other. So if you got 2 angles in one triangle congruent to 2 angles in a different triangle, then the third pair of angles have to be congruent. They have to be the same. So if I gave you some triangle, gave you another triangle, I told you this angle was 50, this angle was 50, this angle was 70, This angle was 70. What do we know about these other two angles over here? They have to be what to each other? They have to be congruent. Does anybody know what they have to be? What's the measure of this angle?
That equals 190.
What equals 190?
Your triangle. If you said 70, 70 plus 70 is 140. Plus 50.
You're adding up too many triangles. How many triangles do I have up here?
I'm just saying one. The one triangle equals 190.
What's this angle?
70,
What's this angle?
50.
What's that give us?
I don't know, but you said that one angle
120.
was 70.
Give us 60 left.
Leaves you with 60. So what's this other angle over here have to be?
60.
No, this other angle had to be 70. Is that what you're thinking
I don't
here?
know, you just said it's 70.
These two were 70, these two were 50. All right, go ahead and copy this down again. Make sure, the symbols and everything, make sure that's where some of you are having trouble. You gotta know the angle symbols, the perpendicular symbols, parallel, all those different symbols that we've talked about. You gotta be able to read stuff like this. What's this down here say? Good, and we can stop there as long as you know. Measure, angle 1, so on and so on. Be able to read all that stuff. If you can't read it by now, then that's really, really gonna hurt as we go on through the class. The measure of an exterior angle, where is an exterior angle going to be located? Say it one more time, Kayla. Exterior, so outside. Outside, an angle outside a triangle. Well, when you have an exterior angle, anytime if I draw my triangle, an exterior angle, this is what you have to do to have an exterior angle. Go to one of the vertex or one of the vertices of the triangle and you extend one of the sides straight out. That makes an exterior angle. This does not make an exterior angle. All right? Yes, that angle is outside the triangle, but it's not an exterior angle for the triangle. It has to be one of the sides. Let's get rid of that. It has to be one of the sides. So if I took this side right here, and I extend it straight out, that would be an exterior angle. So how many exterior angles is a triangle going to have? 3. All right? Now, actually, it could have, this could be an exterior angle, and this could be an exterior angle. So you could have 2 at each vertex, but what's true about those 2 angles? They're congruent. They're the same thing. And we don't want to throw in extra angles there just to make it more confusing. So we put 1 exterior angle at each vertex. So maybe our triangle, if I could draw it, got that exterior angle, that exterior angle, that exterior angle, you'd have 3 exterior angles. How many exterior angles would a rectangle have? 4. How about a pentagon? 5. So it's going to have the same number of exterior angles as it does interior angles. The measure of an exterior angle of a triangle, that's just one of them, is equal to the sum of the measures of the 2 remote interior angles. One of my funnest times of the year is right now. Somebody explain to me remote interior angles. What's the first word mean? Remote.
Almost like I don't know. I think you say remotely, like all the time.
Wow, that's pretty good. All right, alone or away from.
Hawaii.
Usually, what do I get when I ask for what a remote is? The TV remote.
Well, you are away from the TV.
It's that thing that you use for the TV. No, that's what it does. It's a remote control because it does what? Controls the TV from far away from it.
You said it have a remote chance.
Yeah, that's,
Movies.
Jason has a remote chance of getting through this class in 1 year. Right, Jason? Because he won't do his homework. Is that right?
What, is this the second one?
No. So remote interior angles are the angles that are away from and they're on the interior. Well, if we're dealing with this exterior angle right here, which angles are away from that angle on the interior of the triangle? 2 and 1. So those are your remote interior angles. These two angles added together will always equal that exterior angle.
And why is 3 in
1 plus 2 equals 4.
Wait, okay, and then 3 and 4 equal 180.
Exactly. So what do you know about, let's slow down for just 1 second. Kaylee's telling us something. What do we already know about? Forget all this stuff's even here. What do we already know about 3 and 4?
No, they equal.
They add up to equal 180. What do I know about angle 1, angle 2, and angle 3? They add up to equal 180 also. So there's like 3 different equations you could set up there. Angle 3, measure of angle 3 plus the measure of angle 4 equals
So would that
180.
just be like an easier way?
Well, maybe.
If they
It-
give you angle
It depends on what they give you. If they, if they give you a picture and it looks like this, and they tell you this is a right angle maybe, and this is 20 degrees, and they want you to find that angle out there, all you gotta do is add those two up, and that tells you how much that angle is. All right, and then once you knew that this angle was 110,
You could say that angle is
70, you could find that angle. All right, so we could set up that equation. We could set up the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180. Because 3 angles of a triangle have to add up to be 180, all that stuff. But these are called remote interior angles because they're on the interior of the triangle and they're away from that exterior angle that we're dealing with. All right, let's look at the first one. How do you find the first one here? What do you do to figure out angle 1? So add them up. 94 plus 52. What is that, 146? And then subtract that from 180. What's it give us? 34, so the measure of angle 1 equals 34 degrees. That's the answer to the first one. Let's jump over here. How could we find angle 2? 43 plus 90, that's what, 133, then what do you do with that?
Take 180 minus 153. Equals 47.
So the measure of angle 2 right here, I'll write it outside here, equals 47 degrees. How would we find angle 3?
180 minus 37.
Now, do we hope? That's correct, and you could do it that way. Do we have to go through that? Because we know that these two remote interior angles should add up to equal that exterior angle. So we've actually already did the work, and we don't want to have to do extra work. So measure of angle 3 is 133 degrees. How about 4, 5, and 6 on this next one? What's these arcs tell us?
They're all equal, so equals 60.
So they're all equal, so we know that this one is 60. What's this one?
60.
This one?
60.
It's 180 divided by 3. Last one. So Jason, what equation did we say we can set up?
I get 2x plus 3x plus x equals 180. I figured it out there, I think.
So this angle plus this angle plus this angle, all 3 of them should add up to be 180. Even though we don't know any numbers this time, Still should all add up to be 180. What is 2x plus 3x plus x?
6x.
Good.
And then divided by 6 equals 30.
So x equals 30. Now,
They do a fake.
I know I didn't ask you to go any farther because I didn't feel like right now a whole explanation on this. If this angle's 30, that means this angle right here is 30 degrees. But on a lot of the problems, they're gonna ask you to find the other two angles also.
Oh, I do.
Obviously 90 degrees is 3x.
So this one's 90 degrees.
And 2x is 60.
That's good that you did do that. I just didn't explain it out like I should have because I was being lazy and didn't feel like trying to type it. Because once you start typing stuff on a page and after you draw all these pictures, the computer does crazy stuff with it. So I got annoyed with it and it kept, I typed something down here, find all the angles, and then I'd go on to the next slide and then that sentence would end up here somewhere over here or somewhere crazy. Corollaries, again, and I said this at the start of the year, when you're in the back of the book and you're copying down the postulates and theorems in your postulates and theorems section of your binder, corollaries are the same thing as postulates. We're going to treat them just like they're postulates. Now, you go to college and you say, well, my math teacher in high school said a corollary and a postulate are the same thing. They're going to think I'm an idiot because they're not the same things. All right, so they're not the same, but we're going to treat them the same in this class. Just something that we take for granted is true.
Wait, we're going to do this stuff in college that we're doing now?
You know, you'll use corollaries and postulates and theorems.
I'm done.
Your mom probably knows that, Jason. She's expecting that you're going to live at your house until you're 75.
I don't get how people do that. What if your parents die? What do you do?
No, I couldn't live with my parents that long because I can't be grounded at the age of 27. That wouldn't be good. She would do it too.
One of my dad's friends, he lived with his parents until he was like 47.
How do people do that?
Dude, my uncle's
I don't
40
wanna
and
get
he's living
out.
with my
There's
grandpa.
money. My parents drive me crazy.
Dude, that sounds like a freaking dream.
All right. 4-1 corollary. The acute angles of a right triangle are always complementary. So what they're saying on this one, make sure I got my pen this time. If you have a right triangle, what do you know about angle 1 and angle 2 there? If I tell you one of those angles is a right angle, what can you tell me about angle 1 and angle 2 and how they're related? They have to add up to be 90. So angle 1 and angle 2 have to add up to 90 degrees. Remember, that's what complementary means. Two angles that add up to be 90 degrees. So if you have a right triangle, the other two angles, the two acute angles, how do they know that those two angles have to be acute? Can angle 1 or angle 2 be an obtuse angle? Could angle 1 be another right angle? No, because a triangle can only have one right angle or one obtuse angle. It's impossible for it to have any more than that. And that's what this next one says. On the next one, what it says, any triangle can only have one obtuse angle or one right angle. So if you come up with a triangle and you tell me that this is 130 degrees and you figure out that this angle down here is 110 degrees, you did something wrong. Triangle can't have two obtuse angles in it. It can only have one obtuse angle or one right angle in it. And see how those are sort of, it's like corollaries, just like postulates, are sort of common sense. You should know that, hey, if I'm going to draw a right triangle, and that's a right angle, when I go to draw another right angle in here, is it ever going to form a triangle? So you can't have a triangle that has two right angles in it. You can't have a triangle that has two obtuse angles in it because 130 plus 110 is 240. So that means this angle here would have to be negative 60 degrees. That's not going to work. All right, this is your assignment. Yeah, this is your homework. You got about 20 minutes, so you can get quite a bit of it done in here, but on these, I put these first, just so maybe if you work on these now, I can help you with them. Again, the OGT questions are in the front of the book. There's just like 3 of them that I want you to do as part of your assignment. OGT week 7, number 2 and number 5 on week 7. OGT week 8, number 5. So 3 OGT questions. Remember, those are in the front of the book. Then the other parts of the assignment, page 181 and page 189.
I heard your sounds. Like my dog was an idiot, like I'm not kidding.
That's right, just 6 minutes.
Legit idiots.
So that should have been after the notes you showed me.
Haley, is your dog alive? Is Tinker alive?
11 would be good.
Because I was about to get this lab, and I was like, I was thinking just on that thing, I was like, this one's alive.
They're both wives.
I don't know what the person is, though, because my brother's girlfriend, she's like 30 years older, he's like 20. She's like 32, he's like turning 21 this year.
She's into the older one.
I know, Josh. But she has 3 labs, and usually gives one to Jessica for free. She's like, I'll give it to you if you want. And I was like, all right, ask my mom. And Mike said I don't need a potty trainer or anything. So I'm trying to talk him into letting
Yeah, I
me.
know they're all missing. They're like, they clean them all. So it's good girl.
I want it so bad. So for some reason, because her feet are so big, they're right in the palm of them.
Yeah, you can see weird in my